So again, hello to everyone. I wanted to say good morning, but I just heard at 3 a.m. for at least one person here. So hello everybody. I will talk about comparing two risk measures to predict a range of health behaviors and health outcomes. The motivation for this is that in high income countries, according to estimations of the World Health Organization, that's all over the news these days still, about more than a quarter of death are actually due to preventable diseases, for example, strokes or the consequences of coronary heart disease. And then say the college years are very often formative for adopting healthy or unhealthy behaviors. Which gave me a reason to look at college students specifically. The Alameda 7 behaviors are smoking, then drinking excessively, being overweight or obese, experiencing stress, following a healthy diet, exercising, and sleeping enough. These behaviors have been, say, derived from a cohort study in the 1960s in Alameda County in California. This is why they are called the Alameda 7. And then they are they are shown in quite a big number of research papers to be predictors of health outcomes. And then say the goal of this is say to find relatively simple markers to identify individuals that are at risk of adapting or failing to adapt, say for the positive, the healthy behaviors. And then say a promising candidate is this one item, Doman risk measure, that I will talk about in more detail later. In the bigger picture, of course, this is about lab preferences and how they predict field behavior. What's new in this paper is that I have a look at a full set of health behaviors and also health outcomes. Most of the previous literature just has a look at 2 or 3 or 4 risky health behaviors. I do compare the predictive power of 2 different risk measures, one of them incentivized and one of them not incentivized, and then they are also controlled for cognitive ability and for personality traits. So yeah, the plan of my talk, this is pretty straightforward, pretty standard. I'll talk a little bit about the literature, then the experimental design, results, discussion, and conclusion. For theoretical considerations, this is of course related to human capital investment models by Gary Becker, analyzing education, of course, and then the Grossman model that analyzes health investment. And then say when human capital investment is seen as a risky investment, then the theory predicts that higher outcomes risk should lead to lower incentives for investment. So this is the theoretical background. For the previous literature, this is a kind of an overview. Anderson and Meller, they find that more risk-loving individuals are indeed more likely to smoke and to binge drink, less likely to use seat belts. The Harrison paper finds differences for females, but not for males. The Sutter and co-authors paper finds that higher risk aversion is correlated with lower body mass index, but then not with smoking or drinking. This is actually also a paper that has a look at adolescents, which is kind of interesting because this is pretty much what I found for smoking and drinking actually in my paper as well. The Schreck and co-authors paper from 2012 has a look at adults and clients of health centers in South Africa. They found that risk attitude is not correlated with smoking, problematic drinking, seatbelt non-use, or risky sexual behavior. Connell, Price, and Jamison find no differences either. This is my own work. Sorry, I don't like to self-cite, but there's not that much actually, because I also had a look of personality traits, and then they found that when they are taken into account, risk attitude is not related to the probability of drinking, smoking, and engaging in physical activity. For the Doman risk measure, there's actually not that much research yet. Again, Schreck and co-authors 2012, they find that this one actually predicts smoking, problematic drinking, seatbelt non-use, and also risky sexual behavior, not using condoms. Brailovskaya and co-authors, they actually found that the Doman risk measure predicts smoking and problematic drinking too. Okay. For cognitive ability, there's quite a lot of research that actually finds that it is related with health outcomes. Given that I don't only have 20 minutes, I won't go into the details here. For risk attitude, this Doman and co-authors paper find actually that lower cognitive ability is associated with higher levels of risk aversion. And then say for the big five, personality traits. Yeah, there's all this research, and some say, okay, the associations seem to be strongest for conscientiousness and neuroticism. Conscientiousness maybe not that surprising when you think about behaviors that say require mental effort to carry out or not carry out, such as curbing smoking, for example. But then say also for neuroticism, which of course has relations sometimes to mental health. Weston and co-authors in 2015, they also find relationships for extroversion, agreeableness, conscientiousness, and neuroticism. Two other big five traits actually. And so in my opinion, this suggests that, okay, it's probably a good idea to include measures of both ability and big five traits in regressions, where we want to find out about the relationships between risk, attitudes, however they are measured, and health outcomes. Okay, so the risk measures I use here, Holt and Laurie 2002, I suppose in this in this session, everybody should know them. Sometimes in other conferences, people are less aware of this research. The second one, I suppose everybody here knows that one as well. This is the Doman and co-authors. One item risk measure: how willing are you to take risks in general, on a scale from 1 to 10, where higher values correspond to higher willingness. And then the Alameda 7, again, I talked about these already. 2 health outcomes I have, which are general mental health and then general physical health. All of those are self-reported and were asked about in a questionnaire at the end of experimental sessions. So for the experimental design, those were freshmen, but no restrictions were placed on major and so on. It was carried out paper and pencil. We had 178 participants, but then because of lack of answers, we could only use 131 subjects for analysis. The experiments were carried out more than 2 years ago. Shock, time is flying, in March and April 2018. In the experiment, in the first step, subjects took 2 subtests from the Wechsler Adult Intelligence Scale as a proxy of cognitive ability. Those have been shown to be highly correlated with overall outcomes. Of course, if you're a psychologist, you might say, okay, this is not a good measure of cognitive ability, but those 2 have actually been shown to be correlated relatively highly with a full scale test of cognitive ability. The second step were the lottery choices, again, Holt and Laurie 2002. Then in the third step, there was a health questionnaire. Questions were derived from the Canadian Community Health Survey. In a fourth step, everybody took a short version, 15-item short version of the Big Five inventory. Again, this one was validated for use in the German socioeconomic panel, relatively short, but then say, of course, this is a trade-off between time and preciseness, say, of those measures. Those have been shown to correlate well. A background questionnaire, and then say the 1-item risk measure. In the 5th step, everybody was paid and the experiment ended. These are the 2 these are the 2 tasks for cognitive ability. The first is the animal naming task. So in the following 90 seconds, write down as many animals as you can. The second one is the symbol correspondence task. So what you have to do here is say that you have to fill in the symbols under the numbers. Unfortunately, quite a lot of people cheated here. And just did, okay, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, in the hope of filling in more of the symbols. So quite a lot of data actually couldn't be used because of that problem. But yeah. Yeah, this is Holt and Laurie. Everybody knows that one. So everybody had the choice between, say, a low risk and a high risk option. These are some of the health questions. So in general, would you say your mental health is excellent, very good, good, fair, poor? Thinking about the amount of stress in your life, would you say that most of your days are not at all, not very, a bit stressful, quite a bit stressful, extremely stressful? The drinking question: how often in the last week have you had 5 if you're male, or 4 if you're female, drinks on one occasion, and so on and so on and so on. These are the Big Five personality trait questions. So this is: how much would you agree with the following statements? I'm somebody who's talkative, does a thorough job, and so on and so on and so on. To give you some basic demographics about the sample, say for general health, this is around 3, which would correspond again to good health or mental health. About 71% of students reported that they had more than 5 or 4 respectively drinks on one occasion during the week before the interview. About 11% are smokers. The self-reported stress level is also around, a bit stressful. A quality of sleep measure, this is also around 3.4 out of 5. Body mass index around 22. For the 2 risk measures, around 6.8 for Holt and Laurie. So this would be just the number of safe choices. And then say for the Doman risk measure, this would be the average in the sample. About 58% of participants were female, and then the average age was around 19. So these are the results. And here in this table, I show the coefficients of interest only. Again, this contains a full set of controls, including the measure of cognitive ability, the big 5 traits, and some background measures, for example, number of siblings. The outcomes, again, so these are the Alameda 7, smoking, binging, stressing, good sleep, body mass index, nutrition, exercise, general health, and general mental health. What you can see here is that, okay, risk attitude is not correlated with any of them statistically significantly. Self-assessed risk, the Doman measure, is positively correlated with the probability of smoking, and then say negatively correlated with higher levels of stress. The full results here, so these are the full results. Again, here for Holt and Laurie, the second one is Doman. Cognitive ability, interestingly, is only correlated with better nutrition quality. Then for the big 5, openness, not anything. Conscientiousness with body mass index. Extroversion is correlated with quite a lot of them. Nothing for agreeableness. Then for neuroticism, we find something which is found in the previous literature too. This one for female students, they're less likely to smoke, but then more likely to binge. And then they're also less likely to report good general mental health. For the background characteristics, age, we have 1 here, number of siblings, nothing. So this say as a measure of family background. And this childhood question, this is say on a scale from 1 to 5, how happy would you say your childhood was? So also as a measure of family background. This is also correlated with some of the Alameda 7, and then say also general mental health. This is for Doman. This is what you've seen already. This positive relationship with smoking, but then say negative with levels of stress. Again, the rest is pretty much the same as we've seen before. Okay, so in this sample of college students, interestingly enough, Doman and Holt and Laurie, those 2 risk measures are actually negatively correlated. The findings are at odds with some of the previous evidence which shows correlations, such as, for example, the Schreck paper and then also the Brailovskaya paper. One difference you could think about is they used adults, I used college students and relatively young college students, freshmen. This adds, say, to the mixed evidence what incentivized risk measures, about incentivized risk measures. Of course, what you could think about, okay, this is a relatively small sample size, maybe there's lack of statistical power, maybe it's a measurement issue, maybe it's a cultural difference. I haven't said this, but I ran this experiment at my campus, which is in the Republic of Korea. Maybe lack of domain independence. This is also, say, an argument that has been made. This shows, of course, the need to further develop risk measures. There's some of the relatively recent literature. Both risk measures basically fail as predictors of those Alameda 7 health behaviors. There are correlations with big 5 personality traits, namely extroversion. There are some very, very notable gender differences, especially with respect to the self-rated mental health, and then also binge drinking, and then also exercising, where it's found that female students exercise actually less. That's basically it from me. This work was supported by my school, by a research grant, so thank you for that, and I'm looking forward to your question. Thank you.
Hi, Donata. So I have a question. Thanks
Please.
for your talk. So I was wondering, have you also tried to control for measurement error to see whether, for instance, this negative relation between Dolman and Holt and Laurie is robust to that?
I haven't had a, I mean, I have had a look at different measures of the health outcomes. Because what I had a look at is well, in the beginnings, I have to make it more comparable. I was thinking about, okay, let's binarize it all and then they have a look what happens. Nothing really to be found here, but it's a good idea, say, to have a look at the risk measures as well. I haven't had a look at that yet. Thank you.
With respect to the Holt-Lowry and also the negative correlation, are you aware of this discussion started with Anderson et al. That the Holt-Lowry battery is somewhat biased for people with lower cognitive abilities towards risk aversion?
Yes.
Sorry, I was asked if you introduce an interaction term with between Holt-Lowry and cognitive abilities. For example, you can show if the and you can also make a word test in order to see if at some range of the risk measure there is a significant coefficient.
Yeah. Very much agree. Yes, a good idea. I mean, the problem with the cognitive ability is that, say, to begin with, I had to rely only on the animal naming task because so many students cheated on the simple correspondence task. I mean, it's like you tell them, okay, this is not a test. Yeah, it's all anonymized, and still you have around 50 students who just cheated on it. But I will try with what I have with the animal naming task, and yeah, thank you. That's a very nice, a very good suggestion as well. Thank you.
Maybe you want to take this as a proxy also, as whether the students cheated or not, because this tells you something how serious they took the whole study.
Yes.
That would be my biggest worry here.
Thank you. Yeah, no, that's excellent as well. I mean, until now, I just haven't used. I have used them. Yeah, I have used them. But thank you. Yeah, that's excellent suggestion as well.
And maybe this the cheating is correlated with cognitive abilities, no? Because
yeah.
It's not cheating, it's such that are being
yes. I know. Thank you. Okay.
Okay, we now I will tell you that you left 2 minutes, but
okay.
So
okay.
I don't know if we need to wait.
Oh, in course. Okay.
I don't know. Caitlin, you are next. You can decide.
Oh, well. So how many minutes? 5 minutes do we have until the next?
Yeah, 6 minutes. 6 minutes.
Okay, so maybe let's wait 2 minutes, so 3 minutes.
Yeah, no problem.
Maybe that I continue simply with my notes and then I save an email. So I think, did you thought about the multiple testing problem you're running into? And I mean, you mentioned the low power. So I think a way to get around this is to use the technique or the method of specification curve. Where you not only run one model but you run all possible models, all combinations of models. And this way, it's not p-hacking, or it's a systematic way of p-hacking, but you know whether it's a stable relation or whether it's really a shaky one. I don't know whether you heard of it. I can send you papers.
That would be awesome.
This.
Thank you.
And I don't want to do this, but I have a paper that I use a student, the contact of their WhatsApp contact of my student, and they work as an enumerator. So they send invitations to their contacts that have the same range age, and I finish my experiment. Okay, this I only open the platform 6 hours, and I obtain approximately 900 observations. So if and we test internal validity and external validity, and it was okay. The procedure worked. So maybe the next time, in order to have power, you can do this. No.
And do you incentivize them the same way?
Yeah. Yes.
Okay.
But it was a breeze, so it was a lottery, you know.
Okay. Diego, what's the title of your paper so I can find it?
To pay or not to pay, evidence on the lab.
The one. Oh, okay.
Ah, sorry. The one that I mentioned is.
Yes, the one that you mentioned, not the one you're talking. No. Yes.
It's recruiting subject using WhatsApp.
Okay. Thank you.
That's a nice idea.
It is.
Especially, I feel the students, are more connected to their phone.
Yeah. To what's going on in the lecture. I know.
Yeah. Even in the lab,
Yeah. Yes. We force them to have their cell phones in front of the classroom because.
Waiting the response or reviewer. So.
Okay, but. Okay.
In 1 month, I will know if the paper is good or not.
I'll keep my fingers crossed.
Okay, now it's left 3 minutes. I don't know if we want to start, or maybe Steve or Caitlin have another question or comment.
Well, I think, we can slowly start. Maybe I'm going to steal 1 minute from Donata.
My pleasure.
So the experiment that I present today is joint work with Andy Shoto. And we look specifically in that experiment at the auction setting, but we believe that the observation that you make here might also extend to other types of environments. So we call this the Comparability Auction puzzle because we haven't fully yet understood what's really going on. So we're still running some more experiments to really understand what are here the underlying mechanisms. But specifically, we look at the common value auction. So as a reminder, so in the common value auction, you have an item that is auctioned off to all the bidders, and this item has exactly the same value for all the bidders. But what makes the game interesting is that the item's value is uncertain, so bidders have to estimate the item's value. So this is a type of auction that has been used to model different types of markets, like, for instance, markets for mineral rights, timber, spectrum auctions, and many more auctions. But there are also different types of auctions where it's not really clear whether these fit exactly into these type of environments. So here, for instance, I have a screenshot of Taobao. So Taobao is a Chinese equivalent to eBay. And what's so special about Taobao is that basically any investor or anybody can go on the platform and participate in the auction. So here we have an auction on a non-performing loan for a real estate. It has to some extent some kind of a common value auction flavor because the non-performing loan is the same for all the bidders. But it's not really the case that the value is uncertain because here, when you bid for a non-performing loan, you know exactly the face value. You know also there is a default possibility. What you don't know is the default risk. So in order before you go into the auction and bid for the item, you have to collect some information about the default risk, which is a probability. So we were interested in knowing whether the subtle difference in the source of uncertainty leads to different behavior. So I'm just going to give you a quick reminder of the standard way of, or one standard way of modeling common value auctions. So usually we say that we have an item that has a value V. This value V is not precisely known, so the bidders might know the range, the lower range, the upper range. They might have some beliefs about the value V, but they don't know it for sure. So instead, they receive a private signal S, and this private signal is informative about the value V because it's drawn from the interval range around the true value V with a noise of plus minus epsilon. If you now think about the non-performing loan auction, you could model something in a similar way, but here the difference is that not the value V is uncertain, but the success probability. So I stay in the realm of the binary events where we have either a success event or a default, and then the distribution parameter of interest would be the success probability, which is not precisely known. So the success probability that I define here as P is also, also here the bidders might know the range. They might have some kind of a lower probability bound in mind, an upper probability bound. They might also have some beliefs about it, but they don't know it for sure. Instead, they receive a signal, and also here you could model a signal now about the success probability, also with a noise of plus minus epsilon. So you see on the left side, we have uncertainty about values, whereas on the right side, we have now uncertainty about probabilities. In the real world, usually we're going to have a blend of the two where sometimes we have values that are uncertain, but also probabilities that are uncertain. But we believe that in some markets, value uncertainty might be a little bit more prominent, where in other markets, like in the non-performing loan markets, it's a little bit more, the emphasis lies on not knowing the probability distribution. So investors have to collect signals about the probability distribution rather than values. So in that paper, we are interested in knowing where the type of uncertainty really matters in auction. And in order to understand this, in the first step, we're going to consider the extreme cases. So in one case, we only have uncertainty of the values. And we continue to consider this setting as a common value auction. Whereas in the other case, we consider an environment where we have uncertainty over probabilities. And because in order to emphasize that the common uncertainty that bidders face is about the probability, we're going to refer to it as a common probability auction. So our approach would be in the experiment to design two auction settings that are otherwise strategically equivalent, but they only differ in the type of uncertainty in order to see whether the type of uncertainty matters. Okay, so we are more specifically interested in knowing whether subjects bid differently. And we are also interested in the incidence of the winner's curse. So one reason why the common value auction has been studied so extensively is that it produces some kind of a robust phenomenon of the winner's curse effect, where we see that subjects tend to overbid. So they fail to take into account that winning in itself also reveals some information. If you win, it's probably in a symmetric equilibrium. It's probably because you are the bidder with the more optimistic or positive signal. So ideally, you should shave your bid downward in order to avoid overestimating the item's value. Just a note on that. So keep in mind that all the explanations that have been suggested for the winner's curse effect, be it the joy of winning or level K reasoning, so inference problems or curse of equilibrium, or contingent reasoning, do not really depend on the uncertainty being in values or probabilities. So this is why we're also interested in that. Okay, so today I'm going to present to you two experiments. The first experiment is about the auction setting. And there I'm going to show you that bidding behavior is indeed different across these two formats. And then in the second experiment, we're going to look a little bit more deeper into the underlying mechanism, into the reasons why bidding behavior might be different. And there we conclude that strategic uncertainty plays a crucial role in this environment. So the auction experiment is designed to be as close as possible to the experiments that you have in the extensive literature. So we're going to consider basic design where we have 4 bidders. These 4 bidders engage in a first price sealed bid auction, meaning that the bidder with the highest bid wins the item and pays his bid. But now here the difference would be that the auction item is a lottery ticket. And this is exactly the main feature of the experiment, because the lottery ticket is the feature that will allow us to consider 2 auction environments that are strategically equivalent, but that only differ in the type of uncertainty. So the lottery ticket is a binary lottery that gives the winner either a chance of getting a non-zero value V or nothing. And the success probability for the non-zero value V is defined here as P. So we have these 2 parameters, is the success probability P and the non-zero value V. If you knew these 2, then it would be basically in a complete information game. So to make the game interesting, we introduce now incomplete information, once about the value V in common value auctions, and in common probability auctions, we will make the success probability partially unknown. Okay, so let me start with the common value auction. So this is, for instance, an example of a lottery ticket. So what we show to the subjects is that we tell them, where, for instance, in your lottery, you will get with a precise probability of 60%, some value between 30 credits and 90 credits, credits where the expense of currency units. You know that any integer between 30 credits and 90 credits is equally likely to be realized, but you don't know exactly what value V you could become. Otherwise, you would get 0. So here there's no ambiguity. The subjects know exactly the underlying process. Then they receive a signal. This signal is informative about the true value V with noise of plus minus epsilon. They submit their bids, and at the end, they receive some feedback about the actual lottery ticket, the winning bid, the payoff, and the outcome of the lottery. So here, let me show you how the interface looks like. So at the top, they see the lottery ticket, and then they receive the information about the signal, here the signal about V. They don't even have to engage in Bayesian updating, because we tell them right away what it means. And then at the bottom, they have to submit their bid. So in the comparability auction, it's quite similar. The only difference is now that the success probability is not precisely known. So an analog of the lottery ticket would be, for instance, with some imprecise probability P between 30% and 90%, you will now get a precise value of 60 credits, and otherwise you'll get 0. So also here, the subjects know the underlying statistical process, but they receive a signal about the success probability P. They submit their bids and receive an equivalent feedback. So now what is important here is that in that experiment, whenever we do the comparison between common value auctions and comparability auctions, we only compare auctions that are strategically equivalent. And by strategically equivalent, I mean that they have exactly the same theoretical benchmarks under linear expected utility. We consider 2 theoretical benchmarks. The first one would be the naive bidding behavior, meaning the bidding behavior of a bidder who only considers his or her private information. And the second benchmark will be the Nash equilibrium, where the bidder shaves the bid downward. So here I'm showing you an example of the 2 theoretical benchmarks for a set of parameters. The blue line is the naive bidding curve, which is just increasing in the signal. And the red dashed line is the Nash equilibrium, which is just below the naive bidding curve. So what is important here is that the 2 lines are exactly the same, no matter whether the signals are about values or about probabilities. Okay, so because we have different sets of parameters, I'm going to summarize and aggregate all the results by showing you the bid factor. The way we define here the bid factor is a little bit different. We define it as a difference between the subject's bid and the Nash equilibrium. So if it's equal to 0, it just means that the bidders are bidding at the Nash equilibrium. If it's positive, then it means that they overbid. So here's a distribution of bid factors in the common value auction. The black dashed line is the Nash equilibrium, so where they should bid, and the red line is the median bid factor. And what we're seeing here is that we're basically replicating the standard result of overbidding from the previous literature. So subjects substantially overbid in this type of common value auctions, even with a lottery ticket. If you now compare it to the comparability auction, there we see a different picture. Subjects on average bid close to the Nash equilibrium, and they even slightly underbid. If you want to see it as a function of the signals, here I have it for a specific set of parameters. So the dotted line would be the Nash equilibrium. The solid line is the median bid in the common value auction, where we find that subjects substantially overbid. Whereas with the dashed line, we find that subjects in the comparability auction bid close to the Nash equilibrium or even slightly underbid. So now you could think that this really depends on the parameter values. It might depend on the probabilities being low or high, depending on whether subjects engage in probability weighting. But if we repeat the same analysis for all the parameter values that we have, we always find the same pattern. Subjects overbid in common value auction and they bid close to the Nash equilibrium or even slightly underbid in the common probability auction. So this has also a consequence for the winner's curse effect. So if we repeat the same analysis with the winning bids, we find that in the common value auction, we have strong winner's curse effect. Basically, almost all winning bids are substantially above the Nash equilibrium. Whereas in the common probability auction, we also do have a winner's curse effect, but it's less prevalent. If you want to see it as a function of the payoffs, so here, for instance, we have the CDF of payoffs in the common value auction for the solid line and in common probability auction for the dashed line, we see that subjects lose substantially more money in the common value auction than in the common probability auction. Okay, so we have now this auction environment where we find that the type of uncertainty matters. Overbidding is substantially reduced in the common probability auction, but we don't really understand why that's the reason. And this is why we conduct the second experiment. So if you want to understand why subjects suddenly underbid or bid close to Nash equilibrium, we have to think a little bit about the way subjects go when they construct their bid. So first of all, they have to find the subjective valuation for the item, and then they have to convert the subjective valuation into a strategic bid. So we have these two components that play a role, so they're non-strategic reasoning, but also their strategic reasoning. So in the common value auction, it's a little bit more difficult to disentangle these two because in order to estimate the item's value, you need to think about the beliefs about other bids and the information that is contained in the in other bid. So to better distinguish between these two components, we run the second experiment that only focus on the non-strategic part, meaning we remove the strategic incentives. The goal of the second experiment is to keep it as close as possible to the first one. So also here we have two treatments where in one case subjects are presented with lotteries with value uncertainty, and in the other case subjects are presented with lotteries with probabilistic uncertainty, and then we elicit their willingness to pay for these lottery objects in the individual decision-making environment in order to get rid of the strategic incentives. So here we have, even if you focus just on the non-strategic part, we have to be a little bit more precise because differences might arise at different levels. So first, it could be that if we present subjects with these two lottery objects, they might prefer one lottery over the other one, even before they get any information. So then we would model differences at the level of preferences. Second, it could be that differences occur at the stage of information processing, when subjects update signals about values differently than signals about probabilities. Or third, it could be that the ability to reduce compound lotteries also plays a role here, because in both versions, in the common value auction and in the common probability auction, we have this compound risk structure. So we have, in both cases, a combination of a binary lottery and on top of it, a uniform distribution. So in order to distinguish between these three levels, we elicit their willingness to pay for the lotteries before they get a signal, then after they get a signal, and also for the reduced version of the compound lottery. So here, to show you the results, I'm going to do the same exercise as before. So I'm going to aggregate all the parameters together, and I will show you, instead of showing you the bid factors, we'll show you the price factor, which is defined as the difference between subjects' willingness to pay and the benchmark here, which would be the expected value of the lottery given their private information or given the information that they receive. So if the price factor is equal to 0, then it means that they priced the lottery at the expected value. If it's negative, then it means that they underpriced it, meaning that they have some kind of a positive risk premium. What is important to note here is that our benchmark here for the price factor is the same that we have in the auction design when we consider the naive bidding curve. So for a naive bidder, he should only consider his private information when he bids for the lottery. So for a better comparison, the first thing that I'm going to do is I'm going to re-show you the same picture as before, so the results from the bids, but now with the naive benchmark instead of the Nash benchmark. So it's exactly the same picture as before. The only difference is now that the black dashed line here corresponds now to the naive benchmark. So as a reminder, so we had substantial overbidding in the common value auction and slight underbidding in the comparability auction. What happens now if we remove the strategic incentives, then we see that the substantial differences between these two auction formats is basically eliminated. And that's the case when we consider the willingness to pay after they get a signal, so after information processing. That's also the case when we consider their willingness to pay before they get a signal. And it also doesn't seem to be the case that the reduction of compound lottery here would explain differences. We don't see any of that. Thank you. And that's quite intriguing because before running the second experiment, we thought of multiple reasons why we could observe these differences. For instance, risk attitudes could introduce differences across these two formats because the lottery objects do not have exactly the same variance. Or non-expected utility models could also introduce differences across these two formats. For instance, if you consider rank-dependent utility or salience or source-dependent model, if you account different utility functions or different decision-weighting function depending on the type of uncertainty. Or as an alternative, also we thought of the ability to reduce compound lotteries could also be different across these two formats. But note that all of these explanations should also be apparent in the second experiment, meaning in the non-strategic experiment. But this is not what we see. So in the non-strategic experiment, we don't see substantial differences, meaning it casts some doubts on these theories' explanation, the big substantial difference that we observe in the auction setting. So let me conclude. So today I've shown you a context, an auction context, where the type of uncertainty matters. So if you switch from having value uncertainty to probabilistic uncertainty, so uncertainty about probabilities, we see that overbidding is substantially reduced, subjects bid close to the Nash equilibrium. As an effect also, the winner's curse is less prevalent in this new types of comparability auctions. And on top of it, it doesn't seem to be the case that these differences originate in the non-strategic component. It seems to be rather triggered by an interaction between strategic uncertainty and the type of uncertainty. So for the moment, it's not really clear how strategic reasoning interacts with the type of uncertainty. So we're conducting further experiments in order to better understand what's going on here in that setting. But if you have any comments, ideas, intuitions, hunches, anything, anything is most welcome at this stage.
Steve, we can hear you. You have muted the microphone.
Okay, now I'm back. Sorry, I just was thanking the organizers for organizing this event, making it possible to do exchange for researchers of their work. And thank you for attending my talk, which will be about the project This Time is Different on similarity and risk-taking after experienced gains and losses, which is joint work together with Jörg Wieskamp and Adrian Leuenberger, who did most of the work here in setting up the experiment, data analysis, and so on. This project is about how experience affects our risk-taking, which we have like a plethora of literature already about from the field, just to name some, the work of Malmedier and Nagel, and in the lab we also have good evidence from this. So the work from the teams around Kuhnen, she did a lot of stuff in this. So we know that past experience affects our risk-taking, even though it shouldn't really affect it, because risk-taking is always is supposed to be forward-looking. Reasons why one might observe this is experience, that experience affect risk-taking are learning effects. So you might learn something new about the environment or about the options, and you want to explore them. Also, past experience might incorporate new information. So if you think of an asset price that drops, this means somebody else sold this asset, and this could be new information to you about the true value of this asset. Or it might be simply due to changes in wealth. Again, this example of a drop in the asset price means also that your wealth changed and you have a risk reallocation of your risk-taking. What is lacking in all these studies is that they are already like presupposing, so as well in the field as in the lab, they're presupposing to know which past experience matter. And we go a step back and we ask ourselves, like in this project, is it really that every prior outcome matters, or are there some outcomes that matter for our risk-taking? And our hypothesis here is that the similarity of the decision situations from the past to the decision situation you're right now in is the organizing principle that determines which prior experience will affect the current decision. Just to give you already the key results before I go too much into the details, which are in line with our theory and the pre-registration. The less similar a prior decision situation in the task structure dimension is, the weaker is the effect of the prior outcomes on the current decision. And we don't find any effect on risk-taking for non-task structure dimension, for example, changing the background color, so on the perceptual domain. So we add to the literature, for example, like you can just think also as this as a foundation for mental accounting. In psychology, we also add to a stream of literature, and we ask to a whole, we contribute to a whole bunch of actual discussion on similarity in economics. Just to name some here, where they model memory based on similarity approaches or categorization processes, and mental accounting for time delay decisions. So I'm not going into the details of these papers. Let's come to the theory. What we need is, we need like an evaluation function first that combines past experience with the current decision situation. And here we build on the Barbaris 2001 paper, which is also used for the study of Merkel et al. The reason why we take this is that we take the framework also used by Merkel et al. And it seems that this data really fits into explaining the behavior. I like this theory framework fits in explaining the behavior. So the framework, as I said, allows to joint evaluation risk-taking of past experience, gains or losses. And simply by assuming that you are more sensitive to losses than to gains. And the intuition is behind this is that prior gains, they work as a cushion against the expected loss of you might have if you invest into a lottery. So this is the classical house money effect. And the prior loss increased the attractiveness to play the lottery, because you have the opportunity to leave this with a gain or with a smaller loss. So this is this gambling for resurrection motive that you can derive from this motive. Overall, the risk-taking increases in the absolute value of prior gains or losses. This means if you draw a graph, on the x-axis the gains and losses, so the ZT here, on the y-axis you have the risk-taking, you will observe a V-shaped function, so which goes in both directions away from zero. Okay, taking this for granted, where does this ZT comes from? And that's our contribution. So we argue that ZT, so the prior gains and losses, is a weighted average, or no, not a weighted average, it's a weighted sum of the prior outcomes, xi, from the past. And they are weighted by this similarity matching function here, S, which has the following components. So the similarity function has, like, you have a vector describing the current decision situation, AT, so you're in decision situation T, and you have a vector describing the decision situation I. And what this similarity function now does, for each dimension, it calculates the difference between these attributes in this vector. And then you have a further variable here, or parameter, which is the weighting function, the weighting parameter. It's the relevance weight of the dimension for the particular decision situation. So the attributes, so the difference in the attributes gives you like a distance measure between the two decision situations, and the omega measures the distance for each dimension, so how relevant this is for the decision situation. And overall, this function, similarity function, is a matching function, as I said, which maps all the attributes onto the line of 0 to 1. So if S takes on the value 1, then basically both decision situations are identical. And if it takes on the value 0, they are really something different. They are as different as you can. And S moves between 0 and 1. So this S then weights the outcome from past experience. In the sum, it leads to the perceived prior outcome at this decision situation T. So the main propositions are that decision situation I is perceived as less similar to the decision situation T, the larger the perceived distance of the attributes of the decision situations, but also the lower the relevance weight for the variation in the particular dimension to the last perceived distance. And the less similar prior decision situation I is to the current decision situation, the weaker is the impact of the outcome xi on the perceived outcome zt. And this, combining it with the variation, means that the lower will be the risk-taking and the actual decision situation t. Okay, I hope I got this a little bit through. The idea is simply we can actually model this and quantify a similarity and incorporate it into a decision situation, decision framework. Let's come to the experimental design. What do we need? Well, we need a framework where people make subsequent risk-taking decisions. So they gain prior, so they go through experiencing prior gains and losses, and then we need a way how we can change the decision situation. We build on the study of Alex Imas, 2016 in the AR, where people have 4 investment rounds playing the Easy Potter task, and each individual has per round 100 points to invest and can decide how much of these 100 points they want to invest into the lottery. The lottery goes as follows. You're assigned a winning number between 1 and 6. The software throws a virtual die, and if the number on the virtual die matches actually with your winning number, then the invested amount will be multiplied by 7. And if this is not the case, then you lose the invested amount. Overall, this is a positively skewed lottery, so it is attractive to invest into this lottery, but you will more often experience a loss than a gain. So this is how the decision situation looked like. So you have the title, round 1 out of 4. Then you're informed about your winning number. You are reminded that you have 100 points to invest, and then you make the decision how much you want to invest. After this, you are informed about the outcome of the gamble, and then you continue to the next decision in round 2, in round 3. And then after round 3, you're informed over overall account, current account. So you're informed how many points you already earned. And then after this, you continue to the round 4. You continue to the last decision, round 4 out of 4. Again, you're informed about your winning number, your endowment, and make your decision. So as you can see, these are the decision screens. They look very similar. So this is what we call our timeline, our baseline, as the similarity here is the highest. And this is also the same as in the study of Alex Imas, which he called the paper treatment. Okay, now how do we what we do is now we change the last decision situation compared to the prior decision situations 1 to 3. So we first replicate the study of Alex Imas, so where he informed the individuals about that this current account now will be processed, taken to the final overall account, and they will get it at the end of the experiment. And once they heard about this, they had to type in closed. Once they read it, they had to type in closed into this line, and then they proceeded to the last decision round, which was now called round 1. And then again, they were informed about the winning number, the endowment of 100 points, and they made their decision. So 2 things changed. You once had this text about realization, and the title of the last decision situation changed. So again, this would increase for us, or according to our hypothesis, this increases the distance between the last decision situation and the prior 3 decision situations. So we would expect lower risk taking compared to the baseline in the last decision for this treatment. There is a replication of the original study of Alex Imas, which originally failed. It was by Merkel, Müller et al. And there they were also, individuals are also informed about that the gains will be processed now, and then they had to type in closed, but the title of the last decision is not round 1, the title is additional round. So again, 2 things changed compared to the baseline. So we expect a lower risk taking in the last round here, but we expect more risk taking compared to this treatment variation where we call it round 1, as additional round binds the last decision situation closer to the prior decision situations 1 to 3. Okay, then we have a third treatment variation where everything is the same as in the baseline. People are informed about the current account, but then people had to wait 20 seconds till they can proceed to the last decision situation, which is then again called round 4 out of 4. The 20 seconds is simply the time the average individual took to read this text and type it closed. And here, average and median are the same, so very similar in terms of time. So what we were interested is, might it also be simply that time passed between the 3rd decision and the 4th decision? And what we expect is that this passing of time also alters increases the distance, at least in the space of time, and thus there will be lower risk taking as in the last decision situation. Then we have the last treatment variation where we kept everything the same as in the baseline treatment, but we only changed the background color in the last treatment variation, in the last decision situation. And we expect that this doesn't change the decision's task structure. It only is a perceptual question, and we expect this to be irrelevant to the task. So we don't expect that risk-taking, that the risk-taking will change compared to the baseline. Okay, so the procedures, we did this on NTurk. The experiment lasted 15 minutes. What I wanted to highlight is that we really wanted to make sure that we have enough participants to find an effect if there is any. So for each group, we have we aim for 190 193 participants per treatment after after the exclusion, because we excluded people with which invested below 5 points or above 95 points in the first 3 rounds. So yeah, and after we did this, we aimed for having 193 people in order to detect the effects. Okay, let's come to the results now. The average amount invested is 40 to 45 points per round. Average experience gains is 280 points, and the average loss is 160 points. So note that the average gain is larger because of this multiplier by 7 positively skewed lottery. So the range, it's more a scale effect. If we regress the prior profits from period 1 to 3 on the invested amount in the period 4, and this again we have to do it separately for the loss and the gain domain. You can see we have significant effects for both, for the loss and gain domain. It's stronger the effect for the loss domain, which we think is more a question of the scale, because of the scale in the loss domain compared to the gain domain. Let's come to the treatment results, because they are the more this is the most interesting point. So let's start here. What you see here on the y-axis is the change in the invested amount from period 4 compared to the average invested amount in periods 1 to 3. And for the baseline treatment, what we observe is that the individuals invest 6.4 points more in the last round compared to the rounds 3 rounds before, which is positively significant different from 0. So we observe an increase in risk-taking in the last round for the baseline treatment. For the realization restart treatment, if individuals, yep, I've seen it, I will. For the realization restart treatment, we observed that individuals invest 4 points less than in the previous rounds, which is also highly significantly different to the baseline treatment. For the realization and additional round treatment, we observed that there is no change in risk-taking compared to the previous rounds, but there is a highly significantly treatment effect from the baseline compared to the treatment. And there's also a highly significant difference between the realization and restart and the realization and calling an additional round. So the only difference between these 2 treatments is really, here it's period 1 in the last decision, and here it's called additional round. So this already changes the risk taking. For the time delay treatment, people invest more in the last round, so 3 points more, which is significantly different to 0, but we have a weak significant effect to the baseline. So here we have a treatment effect. For the layout treatment, so where the people, where we changed the background color in the last decision situation, but kept everything the same, people invested around 5 points more in the last decision situation, which is not significantly different to the baseline treatment. So in every treatment variation where we change the task structure, we observe a reduction in risk-taking, but where we, for the treatment variation where we changed in the perception, we didn't change anything. For let's come to the last result I'm going before I skip to the conclusion. We did a manipulation check where we asked the participants about whether they did something changed in the last decision situation. And what you can see, okay, for the baseline, they very likely clicked on nothing changed. And also for they recognized the layout treatment. So the change of the background color was highly recognized. But for the realization and restart and realization and additional round treatment, they barely realized any differences. So that's the interesting thing, that even though this perceptual domain was really like visual and recognizable by the participants, it didn't alter their behavior, but the behavior that changed, or the thing that changed the behavior much, was barely recognized by the individuals. So I skipped the covariates individuals. Let me come to the conclusion. Even if you are not buying our explanation with similarity, we have replication results for the study of EMAS, experiment 3, and we partially replicated the study of Merkel-Müller with this additional round compared to calling it round 1 treatment. What we think, what our results are showing is that a decrease in similarity of the task structure reduces the gambling for resurrection or house money effect, and a reduction of the perceptual dimension is recognized, but does not affect risk-taking behavior. So we think similarity as an organizing principle for experience-based learning, belief formation, evaluation is interesting. And this is good news for experimental designs considerations. You have to focus only on the differences in task structure because they affect the experimental outcome. Thank you very much for your attention. Questions and feedback, please write me via email. I'm not so sure how much time we have for discussions. Thanks.
Yeah, we have five minutes. 4. You can use the chat, no?
Yeah, there's no.
So just to clarify, so do you have a sense also to what extent it also lasts? You know, if I play your experiment several times, you probably just did it once, right?
They did it just once, yes. Yeah, but that's a good question. Like, is it just the surprise thing or not? If I get you right, like you are asking, like, is it just
whether the, you know, at the end of the experiment, you know, whether maybe people then integrate it more.
Yeah.
Thank you for your talk. I have one quick question. So do you think that people will actually be able to differentiate between the different types of prior experience and how similar it is to the decision that they make later? So if they would be exposed to different kinds of experiences, that they would be able to use the experience that's actually relevant for the decision that they then have to make?
Yeah, I think so. Right now we are like have kept like the experience very similar, and what you're pointing out is what is if they play Easy Potter and the other time like a Holt and Laurie task or something like that. And if I get you right,
yeah, for instance, yeah.
So I can't answer it based on this experiment. But I think so far as I've read the cognitive psychology literature, that's basically how it works, that you use the similarity and that you construct like an exemplar model in your head of the, about the past experience, which is based on the similarity of your how much past decision situations were similar to what you do right now. But this is just an educated guess, or maybe less educated, more a guess. Does this answer your question? Or?
Yeah, sure. I was just wondering what you were thinking about how this would fit with your model.
Yeah.
Thanks.
Okay. Are there more questions? No. So, thanks, Steve. We can move on.
Thank you very much.
Okay, thank you very much. This is a joint work with Pablo Brañas, Lorenzo Estepa from the Loyola Behavioral Lab, and Victor Orozco from the World Bank, and Erika Rascon from Middlesex University. And in this paper, we test the effect of different payment schemes in risk elicitations. So, measuring risk preferences is fundamental for modeling and predicting how people make choices. There is a lot of evidence that show that risk matter for human capital, health, career decisions, technology adoptions, migration, and many other fields. So there is a growing interest in measuring these preferences, especially in the field. While there is a common practice of using monetary incentives in the lab, in field experiment, the use of such incentives, that is the real money incentives, is less common. Probably because they need to collect a lot of data, thousands of observations, as in National Household Survey or impact evaluation data. So researchers tend to use a hypothetical measure of risk preferences. The standard experimental measure that we know, that is Holt and Larry, Task, Nessie and Potter, and Eckel and Grossman, have used incentive-compatible devices. And these tasks have three important issues. One is that the procedure is costly, because paying subject is costly and the task is time-consuming. Subjects make real choices. That is, in this risk measure, these risk measures are not self-reports, as in willingness to take risk measure. Here we can estimate the parameters of the utility function. And third, lottery payoff using real incentives may create inequality among participants. Subject final earnings depends on their choices, that is, if they select lottery A or B, and nature, that is, the randomly selection made by the researcher in order to pay a high or a low payoff. Therefore, solving payoff at the individual level generate exposed inequality. So the researcher cannot avoid this problem, because any alteration of the random selection process or rule of the payoffs will imply these deceptions. So this issue generates moral concern, especially in the field, and can also create tensions among neighbors, participants, or even between the experimenter and the field participants. So this paper, so this end in the field using risk preferences that been elicited using hypothetical scenarios. So in this paper, we test the effect of using hypothetical payoff on the risk preferences. Using a between subject design, we run 3 experiments. The first is a lab experiment in Seville, in Spain, with 300 observations. The second is a field experiment in Kano, Nigeria, with 360 observations, and a replication in another country, that is another field experiment in Copan, Honduras, with 360 observations. First, in the lab, we validate a reduced version of the whole Larry task that we only have 5 decisions. You know, time is money in the field, so we do it because we need to reduce the cost. So the design of the lab experiment is very simple. We have 5 arms. In the first arm here, we have in this arm, subject made the whole Larry task with 5 decisions, and subjects are paid for real. Everyone is paid. In the second arm, we have in the second arm, subject made the whole lottery with 5 decisions, and only one subject out 10 is paid. This is the breeze mechanism, and this is the B treatment. We call the B treatment. The real, we call the R treatment. And then we have the third arm where a subject are not paid. So they made the whole lottery with 5 decisions using hypothetical payoff. Then we have another 2 arms that we use to validate the instrument. So in the forearm, subject made the whole lottery with 10 decisions, and everyone and all the subjects are paid. And in the last arm, in the fifth, we have a subject made the whole lottery with 10 decisions, and nobody is paid. That means we have the hypothetical payoff. In the field experiment, we use only the whole lottery with 5 decisions. So we have only 3 arms. Each subject was randomly assigned also in the lab. So in the lab, each subject was randomly assigned to one of 5 arms. And in the field, again, each subject is randomly assigned to one of 3 arms. In different 3 arms, we have the whole subject made the whole lottery with 5 decisions using real, the breeze, and the hypothetical treatment. This is a summary of the experimental design across experiments. In the lab, the sample was a student, the questionnaire was paper-based, and the place was the lab. And we don't have a numerator, and we have approximately 300 observations. In study number 2 in Nigeria, the sample was ordinary people. The questionnaire was made using we used tablet, and the place was the household of the subjects. And we have 45 enumerators and 360 observations. And then in Honduras, again, we have ordinary people as a sample, and the questionnaire was using paper, and the place was again the household, and again we have 12 enumerators and 360 observations. So how we measure risk? We use a short version of the whole lottery task. As in the whole lottery task, everybody is asked to choose between 2 lotteries, A or B, and both lotteries, A and B, offer a low and a high payment with a probability of Q. So we use 5 decisions of the whole lottery original task. The first is with a probability of 0.1, the second is with a probability of 0.4, and the third is with a probability of 0.5. The fourth is with a probability equal to 0.6, and the last one is with a probability of 0.9. You know that in decision 4 and 5, the expected value of lottery B is higher than the expected value of lottery A. So we define 3 outcomes variables. So we compare 3 dimensions of the elicitation of the risk task, The first is consistency, which is the fraction of subjects making consistent choices. The risk aversion, which is the number of safe choices, which take value from 0 to 5, where 5 refers to people who is extremely risk averse. The response time, which is the number of seconds spent by the subject to complete the task. So we use hypothetical measure or the hypothetical treatment as a baseline group. So we compare if paying or not, if paying have an impact on risk preferences. So let's see the results. These are the results from the lab, comparing only the 3 first arms. That means that we only use the whole lottery with 5 decisions. And we have the black line is the hypothetical, the blue line is the real treatment, and the gray line is the breeze. You can see that hypothetical and real are very similar. This is the cumulative distribution, You can see that the distribution is very similar between hypothetical and real, but if you compare breeze with real or hypothetical, the distribution is quite different. And we also make a Kolmogorov-Smirnov test, and we find the same result. No, we cannot reject the null hypothesis of equal distributions when we compare the hypothetical and the real. And if we compare the breeze and the real, we reject the null hypothesis. And also if we compare the breeze with hypothetical. This is the regression analysis. We can see that the dummy for breeze treatment have a negative impact and significant effect over the risk aversions. And while the real treatment is not significant, you can see that we don't have a asterisk here. And so at the end, the results suggest that breeze introduce some noise in the risk aversion measure. So now we are going to see the validation of the short version. You only need to concentrate in column 3, 4, and 5. In column 3, we compare the whole Larry with 10 decisions, hypothetical, with the whole Larry with 10 decisions with real incentives. And you can see that the coefficient is not significant for the consistency and the risk aversion measure. Here in the lab, we don't have time. Then if you go to the column 4, we maintain constant the real, so the treatment, sorry. So we compare the whole Larry with 5 decisions with real incentive with the whole Larry with 10 decisions with real incentives. And you can see that, again, we don't have a significant effect on the outcome variables. And the last columns show compare the whole Larry with 5 decisions with hypothetical payoff with the whole Larry 10 decisions with hypothetical payoff. And again, we don't have significant result. So we can, our results show that our short version yield to the same result than the whole Larry original task. These are the results from Nigeria. Again, this is the cumulative distribution function, and this is the number of side choices in the whole Larry with 5 decisions. You can see that hypothetical, breeze, and real are very close. And if we made the Smirnov and Kolmogorov test, in the 3 treatment, we find that we cannot reject the null hypothesis of equal distributions. That means that in distribution, the 3 treatments are similar in the field in Nigeria. These are the regression results. It can be that we don't have a significant effect of breeze over the different outcomes. Here, the last 3 columns, we add the response time, and we can see that there is no differences, no significant differences with respect hypothetical treatment. And when we see the variable for the real treatment, we can see that there is no significant effect. Only the last column, we can see that it's marginal significant, and the difference is only 15 seconds, which is 25% of the mean in the hypothetical treatment. So the difference is no economic, is not important. If we go to the result from Honduras, we can see that the 3 lines are very similar. So the 3 distributions are quite similar, and the Kolmogorov-Smirnov test reproduce this result. So if we go to the regression result, again, we have the dummies for the treatment, for breeze and real, and we have again the 3 outcome variables. We can see that breeze doesn't have a significant effect on the outcome variables. And the second variable, the treatment for real, the treatment for real, we don't have a significant effect. Thanks. So our results are that in the second field we have the same result than in the first field. That means that hypothetical are not different from real or breeze incentive mechanisms in eliciting risk preferences using whole-Larry tasks. So the conclusions, we cover a lab and two field experiment with different subject pools and power. We found that the short version of the whole-Larry with 5 choices generates the same result as the long version with 10 choices. And we found in the lab and in the field, we found that hypothetical and real incentivized measure produce the same risk measure. And when we compare breeze and hypothetical treatment, the results are mixed. Remember that in the lab, subjects become more risk-loving under the breeze treatment. And in the field, we show that there is no difference between both measures. So thank you very much, and comment and question are welcome.
One question, so thank you very much for this talk, and I think you address a very important question, which I have a lot during experimental design discussions, but also with others. One question, you focused in your presentation on the comparison of the group means so far.
Yes.
Did you also look at the variance? Because what I could imagine is that the hypothetical incentivation or the real incentivation changes the variation of the answers, so that in the hypothetical you get a little bit more random answers compared to the incentivized tasks.
Yes, we compared the variance. We made a variance ratio test, and we don't find significant difference. No, that was surprising because we expect that we find in hypothetical group to be the variance to be higher, no, but we didn't find that result. So invariants are similar. So we can say that the treatment, the payment mechanism doesn't affect the mean and the variance.
Which is good news at the end.
Yes, very good news, especially for field experimentalists.
Hi, Diego, I have a question. Thanks a lot. I mean, this difference between Breeze and the others in the lab is also very intriguing and very worrying. So I'm wondering, you know, what would be, for instance, very interesting now after COVID-19 is to see how online experiments do in that comparison. Whether it's closer to the lab or whether it's closer to the field.
Okay, we don't have an online experiment. We have one online experiment for a paper with time preferences, but we don't have for risk. But we need to research more about this topic, no?
Yeah, right.
But for example, in the time preferences paper, we find also that breeds have an impact on time preferences measure, but hypothetical measure doesn't. Are similar, are equivalent because we made equivalent tests. Here we also made equivalent tests because equivalent tests take into account the power, no? So in the time preference, we find that real and hypothetical measures are equivalent, but breeze introduced some noise, especially in the field. It was
especially in the field, but also in online experiments.
Yes. But we also test in online experiment. We compare breeze and hypothetical, and we don't find we find a significant effect only for long-term discount for delta. But that is another paper. Sorry.